Hello, good day to everyone. Welcome to another episode on tips and workflow. In this episode, I am going to discuss on optimizing the packing profile. What packing profile or packing analysis is comprised of, like addition of extra polymer material to the cavity so that we compensate on the shrinkage. You know that during the tooling, we try to expand our cavity so that we compensate on that shrinkage, but at the same times on the machine we try to put excess of material so that we try to compensate or minimize onto the shrinkage. Packing starts exactly after the your suture happens, means from velocity phase to the packing phase we call it. Let's try to do some demonstration on actual model and see that how we can optimize the packing time and packing pressure. I've taken a simple part over here and you can see it's a hot runner fit systems. So what's the best way to get started with? We don't know that what should be your packing time or packing pressure. I usually go with the default setting, and if you check out the default setting of like duration versus packing percentage, you will get a 10 second as a default time and 80% of the maximum filling pressure what we get during the filling analysis. Yeah, this is the best way to get started. And like I perform over here, and then what should be your next step? How should we find that? What should be my packing time and packing pressure? Yes, there's the best way. One of the thing that is always discussed in the forum is look for the frozen layer of fraction. Yes, that's one of the way to look at it. Like I can try to find it like what time the frozen layer or the part is getting freeze. Like in this case, if I see that, okay, near the part area, it's roughly taking like 24 seconds to go. Now this could be a little bit misleading in case of the hot runner or the extended nozzle case. But the other way I can find it out using a cavity weight. Now you can see that cavity weight is when just look at your density of the polymer and volume you multiply, you should get the cavity weight for it. The other way to look at it is like I will go into a new plot and get into the cavity weight, and I'll plot it as XY plot at different location and see that there is no further of material added, or the cavity weight becomes stagnant, or the flat curve is been observed. So I'll look at the different locations and see that my cavity weight. So if you go and try to examine over here that it's 2.7 seconds where the cavity weight is like 227.2 grams, and then it further increases, and I think it should stabilize over here. That's 8.9 seconds, still increasing. I mean, it's changing. 235, 235.3, 34, 35.2. It's continues to be there, and then 35.2. I think after 35.1, and this is like 16.5, there is no further change you can see over here. So I think you can further zoom it and see that. How do we go that? Is just go into your plot properties and XY plot. Instead of going for the automatic, go into the manual, and you see that I want to see that what's happening after 10 seconds, and maximum you can go up to like 20 seconds, and so that you have a closer look at it. And then for the X also, Y also, I will do the same way. I'll start with like 230 and get max up to like 235 or 240, I would say. Yeah, and you can see there's I have zoomed that curve now. It becomes very easier for me now. 235.1, 235.2, and 235.2. Okay, so I would say that it's my packing time should be um, in the range of like 16 to 17 seconds. That's becomes more appropriate for me. So this is the one way I think is the best way to find it out their packing time. Now, how do you go and find the packing pressure for it? We look at the volumetric shrinkage. Okay, at ejection, and you can see that it's in the range of like 0.3 to 5.8. Look at your material that you are using. In this case, I'm using a ABS material. But I want to see that whether my volumetric shrinkage across my part is uniform. That's the best way to look at how do we set up next my packing profile. So I go into a new plot and I will plot a volumetric shrinkage, XY plot, volumetric shrinkage at ejection, and I will say path plot, open it into the new window, and I'll start plotting it. Okay, this is the one side. Okay, you can, and the best way that you export this, like in this case, I just exported as like side one text files, and then I'm going to do the plotting for the side 2. Okay, and then I export it again to the side 2, and same way I'm going to do it for the okay. This becomes my slide 3. And what I did is that I plotted this curve, okay, because in Moldflow it's not possible in single window that I can plot it for the 1 side, 2 side, 3 slides. I have plotted it into the XY spreadsheet, and I can see that side 1, side 2, I think side 1 and side 2 are a bit optimized over here. They are very close to each other, but side 1, the longer side, is a bit away from it. In the profile, you can see that this side is little away, and you can see the higher volumetric shrinkage at the end of the packing profile or end of the part. So it does mean that I should increase my packing time, and maybe initial my packing pressure should be a little higher. So two way to look at that. If you have getting a volumetric shrinkage higher at the end, the one way is to look at like I have to increase my packing time or make it as decay and increase the initial packing pressure so that I compensate this one and later than I reduced it. So try it this way. I hope these tips were helpful for you to optimize on packing time and packing pressure. Have a great day. Thank you.